good evening, and how are you? I welcome you to this particular lesson on physics that goes with the name of the topic, linear motion. For those that had promised that we are starting the lesson at around 5, sorry, you know what's going on in the country, and I got delayed somewhere. So let me start by confirming if there's anyone who can hear me very well. If you can see my board, let me confirm this way. So what is happening is that there's always a microphone that I always place here, but for now we'll likata. But what I will do is that I'm going to just use the microphone of the camera, and I hope, I'm willing, I'm wishing, I'm praying to God that you can hear me very well. So if you are the first person, or if you are already in the lesson, kindly confirm to me that you can hear me. That's the first thing. That you can hear what I'm saying. That is the first thing. Number 2, confirm that you can see what I'm writing on the board. Those two are the main things. That you can hear me and you can see what I'm writing on the board. For example, if I write this way, if I write ambassador speaks, can you see what I'm writing on the board? Like, is it visible? Because sometimes balancing the light is also a problem, but I hope you can see me. I'm waiting to see a text showing that you can see me. Welcome to Ambassador Speaks, and also welcome because there are fans from the Shifting Grades online school who are following up with me right now. So I can already see they're already in class, those guys who are in Shifting Grades. I can see Abdi Hazis Mohammed. Mohammed, can you hear me? Can you listen? Can you see what I'm writing on the board? Thank you so much for confirming. From the side of Ambassador Speaks, I can see you are also in class and moving on very well. So I'm here with someone at the camera who is actually working on the camera and at the same time inviting people to join our lessons today. Let me start by explaining what is linear motion. First of all, it comes from the word line. A particle that moves in a straight line is said to be possessing what we call linear motion. For those who are in Form 4, we have already taught you about what we call uniform circular motion. Circular motions. That's why we say that a body can have 3 or even more types of motion. One of them is linear motion. Another one is circular motion. Then we have what we call translational motion, and we have rotational motion. But for today, we are only going to focus on linear motion. Also, I will not be in a position to finish or finalize with this particular topic today. Like, it will take me time. I may do it today, tomorrow, and maybe Friday. It's a very long topic, very engaging, and of course, very interesting. Like, it's so interesting. Yes. So, where are you watching me from? I want the following details from you to keep me going. I'm not asking much from you. Just focus on the lesson. Number 2, where are you watching me from? I mean, where you are right now. Maybe you are in Nakuru. Which is your school? Where I mean, that's where do you school? Maybe your school is Limuru Girls. Then, who is your physics teacher? Because you know it's good we recognize our teachers here. Like, who is your physics teacher? You know, hiyo lazima tu tujue ndio tujue. Elva Sitiene anasema very loud and clear. Thank you so much for confirming that one. From the other side, Mohammed anasema very yes. Thank you so much from the side of the Shifting Grades online school. And now we are on the side of the Ambassador Speaks, whereby Elfas has confirmed that he can hear me very well. Now, as you are focusing on that, tell me who is your, who is your physics teacher? Now, I want us to start by learning the following 5 terms. There are 5 terms we are going to start with in this particular topic. That for you to learn linear motion, you must know the following. First of all, there's what we call distance. What is distance? Number 2, there's what we call displacement. Displacement can be symbolized by capital S. Then we have number 3, we have speed. Then we have number 4, we have what we call velocity. Then number 5, we have what we call acceleration. These are the main 5 terms that I want us to start our lesson with. Yes, like distance, displacement, speed, velocity, and of course acceleration. Like these are the things that you need to start with, you need to know, then the lesson will flow very well and it has no issues, like it will have to move on very well. So now, tuanze na kwanza. Like let's start with, let me confirm the following. Abdihasi anasema Wajir High School, Evelyn Soul anasema, Evelyn Soul ajaonge. Okay, amesema from Kakamega live. Thank you so much. There's some many guys here. We have Jim Jung, Nyandarua High School. Thank you, Jim, from Kakamega. Hey, I mean, there's so many. Let me proceed, then I'll come and read. Hey, someone saying that on Friday I will be back to school. Why? Why would you go back to school on Friday? But anyway, when you go to school again, we have your physics teachers who will take you through. Don't worry about that one. Let's look at the linear motion. I want us to start with the water distance. We shall be, defining each term one by one as we are moving on. Distance. This one is the actual length covered by a moving body. Actual length covered by a moving body. I don't know whether you can see here, unless you can plug So we have point A, then we have point B. Now if you move from point A to B, in two routes, kuna hii kwenda direct na kuna mtu ameenda hivi through a zigzag manner. The actual length, if someone has moved from A to B, na ameenda hivi, amepita the zigzag manner, akaenda hivi, the actual length you have to follow where that person has passed through. Actual length, and its SI unit is in meters. Now, let me go to displacement. Like, displacement is defined using the term distance. Distance covered in a specific direction. Now, if you move from A to B, hata kama umepita hii zigzag manner, displacement is we measure the distance directly from A to B without going through the corners. Like, look at this. If we have this, we have A, we have B, then we have C. Pythagoras theorem. If here is 3 meters, up at 4 meters, automatically up at 5 meters. If you move, let's use this. If you move from A to B, then to C, the distance covered is 3 plus 5, 8 meters. But the displacement, after we enter from A, B, and C, the displacement is going to be 4 meters. Distance covered in a specific direction is called displacement. Like in the actual distance, if you move from A to B to C, the distance is 3 plus 4. The displacement is only 4 meters. Like from where you are standing compared to the starting point, what is the distance? 4 meters. And if I move from A to B to C and back to A, the distance covered is going to be 3 plus 4 plus, 3 plus 5 plus 4. Yes, but the displacement will be 0. Like I started at A and I'm at A. I've covered, like I'm at the starting position. I'm displaced at 0 meters. 0. Distance is a scalar quantity. Displacement is a vector quantity. Now, speed. Speed. I'm unable to read all the those who have commented, but at the end of the lesson, I will be able to read through them. Keep on answering. There's no problem with that particular one. So now, speed, speed comes from distance. Distance covered by unit time, that one gives us speed. Displacement covered by unit time gives us velocity. And there are others who will tell you that change in displacement with time will give you velocity. There's no problem with that. Change of distance with time will give you speed. That's a fact. Now groups. So what's the percentage of that one?
9.
Why can you do that after some few minutes? Now, what about acceleration? Now, if you want to get acceleration, acceleration comes from velocity. You know, velocity is given in, let me write here. Velocity is given in meters per second. This one. Speed of force is still meters per second. This one is in meters. This S is a symbol for this. Like when you see S, it is standing in for displacement. Now, when we talk about acceleration, acceleration comes from velocity. Velocity over time. Velocity covered per unit time will give us acceleration. And therefore, you can imagine, if velocity is meters per second, again when you are dividing by time, and time is seconds, well, this one is going to give us meters per second square. That is what? Acceleration. That is what we call acceleration. Now, these are the 5 terms which we shall be interacting with most of this particular topic. This is our first lesson. That's why hapo kwa description I've written linear motion lesson 1. Meaning, tomorrow lesson 2 is coming. Lesson 3 is coming. Mpaka ile siku tutarudi from after. After tumerudi from after, then what will follow is that we are going to have we will be having several other lessons, and we are thinking of incorporating other teachers from other subjects also. Hata CRE tunaweza amua tuanze kufunza CRE. The one in charge of shifting grades can read CRE. He's very good in he always reads the Bible. Now, change in velocity per unit time gives us acceleration. So I think I can wrap this one. Then we move on with other things. The topic is linear motion. I can wrap everything here, but keep confirming that you can hear me. Usually our network may be disrupted by very many things. So acceleration A is given by change in velocity over time. Change in velocity means final velocity minus initial velocity over time. Now, velocity is given by V. But when we start the issues of final and initial, then final velocity is given by V and initial is given by U over time. This gives us what we call acceleration. In fact, in this topic, it is the first formula. A is equals to V minus U over T. Going forward in this particular topic, hello? I'm fine. Chemistry and physics. Yes. Do this, eh? Can I call you at science 6:30? Let me call you at 7:30 when I'm done with the lesson here. I will call you. Yes. I will come. Sorry for that. I was nakuwaga mtu watu kwaga na watu wengi on my side. What was I saying, by the way? You know, when I'm interrupted, I have to be reminded what I was doing. But don't worry. Hey. So I'm saying this is your first formula that we are going to, or that we have used in this particular lesson. A is equals to V minus U over T. T is time, and of course, time is in seconds. Don't use time in minutes or in hours. It is always in seconds. And speed for the meters per second, because distance is given in meters, time in seconds. So speed and velocity, they are given in meters per second. So acceleration would be giving you in meters per second square. Yes, those are the 5 terms which I believe everyone right now knows what we are doing. Now, let's proceed from where we were. I want us to talk about there's one term I want you to know. Change of velocity per unit time is called acceleration. It's a vector quantity. Now, kuna kitu inaitwa instantaneous velocity. Instantaneous acceleration, not velocity. Instantaneous acceleration. What is this? What is instantaneous acceleration? I mean, what comes to your mind when you talk about instantaneous acceleration. It's very simple. It is acceleration at a point. Acceleration at a point. Mostly it is used when you have a graph and it is a curve. You always get acceleration at a point. Now, also, let me say this. Instantaneous acceleration, you know, the acceleration you will always give is average because we are getting the final velocity minus the initial over time. But acceleration at a given point, at a given time, is known as the instantaneous acceleration. Now, let's talk about this. Let me use 1 minute to explain this. And I hope I'm audible enough. I want to explain something, so let me confirm from my fans, those who are following me. I hope I'm audible enough. Yes, kina Simana anasema yes. Madamos, my physics. Oh, Salome Madamos. Now, I'm saying this. Look here. If a body at the beginning equal a speed of 10 meters per second, in U, baadaye equal na 25 meters per second, and this is V. This body is said to be accelerating. But imagine this. If at the beginning it is 25 meters per second, which is V, then baadaye equal to 10 meters per second. Like, no, equal U is equal V. Imeanza 25 meters per second. After some time, imekuwa 10 meters per second. This body, ya kwanza is said to be accelerating. Accelerate. Like I'm saying, the velocity increases with time. Now, ya pili, the velocity decreases with time because it started with 25. Now we are at 10. What can you say? It is decelerating. This one we will call acceleration. This one we will give a name deceleration. Deceleration. Or let's say in this case, the time in each case is 3 seconds. 3 seconds. So if I have to calculate acceleration here, I will say I'm doing for the A. In A is given by V, which is 25, minus 10 over 3, which is going to be 15 meters over 3 seconds. So which will give us 5 meters per second square. No, this one is 15 meters per second. That is, yes, good. Now we have B, this one. It's going to be yes. Now, here B, the acceleration is negative 5 meters per second. Actually, yes. So I hope we are doing well now. So let's proceed. Let's look at this. There is something here I want to look on. I want to give a question concerning this, what I've just discussed, and I want you to listen very well. there's a question here. A body moves 30 meters due east. Due east in 4 seconds. Using 4 seconds. Then 40 meters due north. In 8 seconds. Now, the question is the total distance moved by the body. So this body ilienda 30 meters this way, due east. Then ikafika mahali ikaanza kumove northways. Ikaanza kumove upande wa hivi. And this is 40 meters. Now, this body, the first question is this. Calculate the total distance moved by the body. I hope you can hear me. I can just check from here whether I'm doing on very well. Let me check. I hope we are doing fine. Zuri. Distance moved by the body. I hope you can hear me. I can just check from here whether. Yes, so let's answer this question. I was just checking whether we are on everyone. So let's look at this. The total distance moved by the body. Total distance is going to be 30 plus 40 to give us 70 meters. Then the displacement of the body. Now displacement is from here back up direct. Like the body started from here, it ended here. Now, the distance in a specified direction, this way is straight this way. Up at the we use Pythagoras theorem. 3, 4, 5. Or there are some other ways in which we can find it. Maybe you can have this angle, then we can use the SOHCAHTOA rule. But for now, from the Pythagoras theorem, this part will give us to be 50 meters. So that is now the displacement. Then the average speed of the body. Average speed is the total distance, which is going to be 70 divided by the total time, which is now 4 plus 8. You divide by 12 here. You will get the total what? Speed. Yes. Then, concerning the velocity, the average velocity, it's going to be the displacement here divided by what? Divided by time, which is 50 divided by time, which is still 12. And you'll get what you are supposed to get. So let me ask if there's anyone with any question before we actually move on. So if there is none, I can move to something else. Anybody with anything to say? Yes, if there is none, we can check on something else. There are very many examples here, but for now I cannot give you the examples. Yes, just a minute, I'm checking on here. So I'm just seeing whether we are moving on very well. And there are guys here who are following me very well. We have Jim, JMK Anzema, Mr. Mureidi, Ian is his teacher. Jim anasema, oh, Madam Rose, my physics teacher, sawa sawa. Kuna mtu anaitwa Marco Rwai, anatoka Rwai Hills, few physics teacher anaitwa Sam. Silas anasema Friday, yeye atakuwa amerudi shule, and also lemi mwalimu wako wa physics, na utie bidii sana kwa physics, na chemistry, na masomo yote, na hesabu pia, you know. Then, Mr. Mwangi, chairman, Mr. Malika, the Great Nduluni Secondary School. So, huyu ni mwalimu wa mwalimu. Like, mwalimu anasema mwalimu wake alikuwa nani. Those days, Mr. Mwangi. Anyway, no problem. Then, Evan is all from Kakamega. I think I tried this, all of them. And, yeah, thank you for joining. And, it's good we are together in this. Now, acceleration can also be measured. It can be measured using Attica timer. We all know Attica timer. We know how it operates. Now, in fact, I just want to explain how Attica timer operates in the next 20 minutes. Then, from there, we will end the lesson for today. Tomorrow, we will come and see the equations of linear motion and how they are applied in different types of motions. Like if you project a body upwards, downward, or horizontally this way, how will it be like? Sawa, hiyo tutaangalia kesho. Then in fact it will be our last lesson for the linear motion tomorrow. Then the other day niingie kitu ingine. So now kuna kitu inaitwa Tika timer. I want to mention very few things about Tika timer. Then after mentioning these very few things, after mentioning the very few things about Tika timer, then we will do 2 or 3 questions. So Tika timer is a machine that is used to show acceleration or to calculate acceleration in machines. In the lab, most of us have seen Tika timer. Kama hujaiona Tika timer, the way I'm going to illustrate will be like you will understand what I'm talking about as a Tika timer. Now, Stephen Cody anasema Mongori High School. Which your physics teacher Stephen Cody? Tell us your physics teacher. Tunataka kujua your physics teacher ni nani. So we are here. Tika timer, it leaves marks on a piece of paper, and those marks would be used actually to calculate acceleration. There is a machine called Tika timer that pulls a tape. While pulling the tape, the dots are made. This machine that is making dots this way, like we have a tape being pulled this way, and then the Tika timer is very constant. It vibrates at a given frequency. Mostly, we talk about 50 hertz frequency and 100 hertz frequency. Like, the machine does not change the speed. It is the machine that pulls the tape measure. Sorry, it's the machine that pulls the tape. The one that changes the speed. Now, it makes constant dots. So whenever you see a tape, imekaa hivi, if the dots appears to be equally spaced, then it means that tape was being pulled by a machine that was moving with a constant velocity. Now, you must be shown the direction of the speed this way. This one was a uniform velocity. Why? The distance between the dots are the same. When they appear, it's being pulled this way. So unapata at the beginning, the dots were very close. Ikafika mahali, the dots ikaanza kuwa mbali mbali. This one, when the dots were very close, it means it was moving slowly. When the dots start to move far away from each other, it means it was moving very fast. So this one was increasing in constant velocity. In increasing velocity. Then kuna hii ingine. Ilianza ikiwa mbali mbali hivi. Ikaanza kukaribiana. This is decreasing velocity. Yes, so those are 3 types being pulled by a Tika timer moving with different velocities. Yes. Now, how do we calculate velocity or acceleration using a Tika timer? A Tika timer, first of all, it must give you what you call frequency. Yes. As I'm talking about frequency, please remember about the wave equation. V is equal to F lambda in form 2 in the topic of the waves. You must understand that one very well. But now in this case, after learning this, now I want to show you. In fact, I'm just doing 2 examples. After I'm done with the 2 examples, you will have known how Tika timer operates. you will have known how ticker timer operates. Haya, tuko hapa. I will explain to you how ticker timer operates by using examples. So allow me to open an example somewhere here. We will do at least 3 examples, then from there you will be well to go. In the meantime, I just want to keep on inviting you to our learning platforms. That is our learning YouTube channels, the 2 of them, Ambassador Speaks, and of course the Shifting Grades online school. I'm opening questions on linear motions. I hope it is. Oh yes, they are here. I thought somebody had deleted them, but yes. So kuna hii swali ya kwanza. I want to start with the first question. I'm only doing 3 of them. Kuna hii umepewa hivi. I hope you can see it. Then umepewa dot hapa. Dot ingine hapa. Then in between ngapi? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. After ya 6, kuna ingine hapa. Then unaambiwa from here mpaka hapa ni 40 centimeters. Then from here mpaka hapa ni 5 centimeters. Then unaambiwa frequency yake ni 100 hertz. Then question is determine the acceleration of the trolley. Determine the acceleration of the trolley. Then kuna arrow umewekewa hapa. Now let me give you a disclaimer. Even if this arrow is not placed, always treat this part huku equate the part to show what we call the initial velocity. This is the initial velocity, that is the final velocity. But of course the arrow will be guiding you, because an examiner can say it to give you an arrow this way. So this one will become initial, this will become final. But for now, it's not that way, it should be this way. Like I have to remove this arrow. I hope we are together in that. Yeah, so towards an initial velocity. But how can we know the time now? Because for us to get the initial velocity u, we must use the distance, which is 40 centimeters, which is now 0.4 meters, over time gani, when the ticker timer has a frequency of 100 hertz. The time between each dot is going to be 0.01 seconds. So this one is going to be 40 meters per second. Now the final velocity on that side is going to be 0.05 meters. Are you seeing? In the 5 centimeters. So convert it and make it meters. It becomes 0.05 meters. Then you divide the time, which is 0.01. You get what? 5 meters per second. So this is the final velocity. Why are we saying so? Between one dot and the next, that ticker timer, whatever is making the dot, inakwanga hivi, inaenda juu, inarudi. So from making one dot to making the next dot, that's a complete oscillation. It has moved a complete oscillation. So if the frequency is 100 hertz, like frequency means, if you are told to define frequency, the number of complete oscillations made in 1 second. But now, the periodic time I'm looking for, which is 0.01, is the time made or used to make one oscillation. So it is 100 it is 1 divided by 100. Kuna zingine utapata ziko na 50 Hz. Ikiwa na 50 Hz itakuwa 0.02. So here we have now V 5 meters per second, U 40 meters per second. Now A will be given by V minus U over T, which is going to be V, which is 5, minus 40 over. This way now I want you to be very keen. So much, like, what is the time here? That's where I want you to get me very clear. How would you say now? How would you say this? First of all, let's count here. We have 1, 2, 3, 4, 5, 6. Then, don't take the complete for the sides. Take half on this side, a half on this other side. So you will have 6 plus half here, plus another half here. So you will have 7. 7 spaces. And remember, one space goes for 0.01. So here it's going to be 7 times 0.01. Then from here, 5 minus 40 is negative, that's 5. Over 0.01. Then that one now will be, 0.07. Up on 0.07. That is like that 500 divided by 7. Now, that 500, of course, negative divided by 7. It occupies 500 meters per second square and negative. So the acceleration is 500 meters per second square. That is the acceleration, negative 500 per meters square. The deceleration is, if I use the word deceleration, then I will remove the negative. The deceleration is 500 meters per second square. You can hear me? Yes? Yes. So, apart from that one, then that's the first example on the ticker timer. I still have 2 more to go, unless you have a question. Kama kuna mtu ako na swali, we can, ama kama kuna mtu ana swali, we can proceed. Nataka niingie example ya Okay. Now, let me explain how you will do this. Because nimeona network imeanza kuleta upumbavu. First of all, get the velocity here, which is going to be the initial velocity. Get the velocity here, which is going to be the final velocity. Then apply A is equals to V minus U over T. V ndio ya pale, U ndio ya hapa. Now how will you get T? Already umeambiwa the frequency is 100 hertz. So meaning it's going to be 0.01 seconds per dot. I mean between two dots. So count these dots in between B and C. You'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huku we have 2.5. Huku tuko na 2.5. Chukua nusu ya huku 2.5, nusu ya huku 2.5, then plus 10. You get 15. Then so it's going to be now T, how you get T here is going to be 15 times 0.01, and of course it will be time in seconds. Then you have your V, you have your U, then you will get that particular acceleration. If it is negative, then it means the body was decelerating. If it is positive, then it means the body was accelerating. See you tomorrow at 9 a.m. for chemistry, carbon and its compounds. Then tomorrow evening at 5 p.m. for physics, linear motion part 2. May God bless you.